All right, so we have another example on higher derivatives. This is a funny one actually. It's just something you need to know that the in MT25 you actually need to solve a lot of things like gain experience. That's what my teacher that told me 106. That's what he told us. You need to solve like so that you don't see a question and you're like, Jesus Christ, what do I do? So this is one of the things you just need to learn. So you will apply it in so many places, but let's start from here. All right, so you're giving let x be equal to r cos theta, y be equal to r sin theta. Find the square r over the x square, the square r over the y square, the square theta over the x square, and the square theta over the y square. Solution: x is equal to r cos theta. It implies that this sign means it implies that cos theta is equal to x over r. Y is equal to r sin theta. It implies that sin theta is equal to y over r. So I brought out this so that when we are drawing, we can draw the right angle triangle. The angle is theta. So catua. I had to write it down. So catua. Cos is adjacent over hypotenuse, so adjacent is here over hypotenuse r. Sine is opposite over hypotenuse. This is the opposite y over hypotenuse r. So by Pythagoras theorem, the sum of the other two sides is equal to the square of the sum of Jesus Christ. The sum of the squares of the other two sides is equal to the square of the longest side. That's it, Abi. Don't worry, that's as much as you need to know concerning Pythagoras theorem. So you have x squared plus y squared is equal to r squared. Call it equation 1. From here to tan theta is equal to y over x. So you're asking, why are we doing this? We are doing this so that we can get implicit equations or implicit functions, because before you use partial, you need to have one equation that bounds the variables together. So with this equation now, r is a function of x, r is a function of y. With this equation, theta, or let's use this one, tan inverse of both sides, theta is equal to tan inverse of y over x. Theta is a function of y, theta is a function of x. So it's very much possible to solve for any of these. That's why we are doing this. We can't just solve for them from here for this type. Oh. Alright, so differentiating equation 1. Equation 1 is x squared plus y squared equals to r squared. Differentiating partially with respect to x, you're going to get this is 2x, this is 0. We have 2x plus 0, just 2x is equal to, differentiate it with respect to x is going to be 2r. But now you show that you differentiate the partial with respect to x, so it's 2r partial r over partial x. Okay, that's why I left this space so that I can show some working. So equation 1 is actually x squared plus y squared equals to r squared. Differentiate this partially, you have 2x plus 0 equals to 2r partial r over partial x. So you have 2x equals to 2r partial r over partial x. Okay, so make the r dx subject to formula. You divide both sides by 2r. Partial r over partial x is equals to 2x over 2r. 2 cancel, so you have x over r. Recall that you're giving x is equal to r cos theta, so cos theta is equal to x over r. So x over r here is also cos theta. Then solving for the r and the square r over the x square, differentiating this again with respect to what? Differentiating with respect to x. So this is division, so you're going to use quotient rule for this. It's going to be v du dx. So differentiation of x with respect to x is 1 minus u. Differentiation of r with respect to x is 0 all over v square, that's r square. When you multiply this is r minus 0, which is r over all over r square equals to 1 over r. In terms of x and y, recall x square plus y square is equal to r square. R is equal to root x square plus y square. So in terms of x and y, 1 over r is equal to 1 over root x square plus y square is what I'm saying. Then differentiate equation 1 partially with respect to y. Our equation 1 is still x square plus y square equals to r square. Differentiating partially with respect to y, you have 2y, this is 0, so you have 0 plus 2y is equal to 2r partial r over partial y. So 2y is equal to 2r partial r over partial y. Make partial r over partial y. Partial r over partial y is equal to 2y over 2r. Cancel. Y over r. Recall y is equal to r sine theta, and so sine theta is equal to y over r. So this could also be called sine theta. Yes, so that's what I did here. Then differentiate it again with respect to y. You use your quotient rule, you're also going to get 1 over r in terms of x and y too, if they ask you to put in terms of x and y. So this is this, and we actually solve for I, and we solve for I. So shall we solve for I is tan theta. Recall tan theta from here. Tan theta is equals to y over x. So here too, tan theta is equals to y over x. Theta is equals to tan inverse of y over x. Partial theta over partial x is equals to 1 over, differentiation of this is 1 plus this square, times differentiation of this with respect to x is minus y over x square. Straight up, you will know you find the LCM, inverse it and multiply to get x square over x square plus y square times minus y over x square. When you cancel out, you have minus y over x square plus r and y square. Now it says you find the square theta over the x square, so it's v. The differentiation of this with respect to x is actually 0 minus u. The differentiation of this with respect to x is 2x all over everything square. So minus and minus is positive. So positive y times 2x will give you 2xy all over x square plus y square. That's the square theta over the x square. Alright, solving for the square theta over dy is going to be 1 over 1 plus y over x square times 1 over x. Recall we are differentiating tan inverse of y over x. So differentiation of y over x related to y is 1 over x. The same thing, you have x square over x square plus y square times 1 over x. X cancels x square. You're going to have x over x square plus y square. So now the square theta over the y square is equal to, yes, differentiate this again with respect to y is v. Differentiation of x with respect to y is 0 minus u, which is x, times differentiation of v with respect to, that's differentiation of this with respect to y is just 2y all over v square, which is x square plus y square, everything square. When you multiply, is negative 2xy, so minus 2xy all over this square. That's your final answer for partial square theta over partial y square. So one last question on this. Given that f of x comma y is equal to 3x square y raised to power 3 minus 4xy square plus 2xy, find partial square f over partial x partial y and partial square f over partial y partial x. Please, maybe after you watch, try to solve it again. You may understand it from the verbal explanation I'm making, or maybe some little write-up, but it's always better you solve it by yourself and see it like that. It's, I guess, I'm just saying, sure, that's how I normally do. So you have f is equal to this. Partial f over partial x is equal to invention of this with respect to x. So you have 2 times 3, that's 6. 2 minus 1x, y raised to power 3 minus 4y squared plus 2y. Invention of this with respect to y. So when you look at it, you know what you need to find. You need to get the f dx and the f dy. So you get the f dy is going to be 9x squared y squared minus 8xy plus 2x. Now the square root over dx dy is equal to d over dx of df dy. So df dy differentiated with respect to the x is going to be 18xy squared minus 8y plus 2. The square root over dy dx is dy d over dy of df dx. So df dx differentiated with respect to y, that's going to be 3 times 6, 18xy squared minus 8y plus 2. If you notice, they are equal. So we've gotten it. So I had to put in notes at all points in time. The square f over dx dy is always equal to the square f over dy dx is always equal to, it's always equal to. So that's it for this.